So welcome to tonight's free LSAT prep hour, Manhattan Prep free LSAT prep hour. My name's Scott Miller. I'm going to be your instructor tonight. I'm based in Durham, North Carolina. And just a little bit of introductory information before we roll into the main content for tonight. So we do these free LSAT prep hours twice a month. We have different instructors come in and do an hour of conversation about the LSAT. And we have some other really good free resources that might be helpful for you while you're preparing for the LSAT. And I'm going to put some links, if you're here live tonight with us in this session, if you logged in for this session live, I'm going to put some links in the chat window at the end of class to some of these free resources, so you don't have to worry about writing this down right now. If you're joining us, if you're watching this as a recording on YouTube, then in the description for the video, you should see some links to some of our free resources. One of the things you'll be able to do is try an LSAT class. We do live online classes and also in-person classes. You can attend session 1 of any of our classes for free. You do have to register and sign up, but there's no charge. And then we also have interactive on-demand courses, our LSAT Interact courses. So those are a couple great options if you're interested in more. And we have a bunch of other good free options on the website. Like I said, I'll give you some more information about that at the end of our session. But let's talk about tonight. Tonight so the last time I did one of these, I think it was in January, I did a session on time vampires and timing strategy and how to use every minute effectively on the LSAT. And it was really, that was more geared towards logical reasoning and timing and logical reasoning. What we're going to talk about tonight is the logic games edition. So how to use your time effectively, how to develop a good timing strategy on the LSAT. We also call this killing the LSAT time vampires. And we're going to be using questions from the June 2007 LSAT. The reason we do that is because it's available for free on the LSAC website. You can download it for free. So it's one that, even if you haven't purchased any books or anything, everybody can have access to that site, that June 2007 test. And that way you can go back and, if you have a copy of that sitting around right now, you can look at that while we're working, or you can go back and review this later on your own. So timing is a pretty common issue on the LSAT. Probably one of the most common complaints that we hear from people, when we're working with students in our courses or working with tutoring students. This is probably the most common complaint I hear from people. People say, I can do the questions untimed if I don't time myself, but when I start timing myself, I start making a bunch of mistakes and getting questions wrong. Or the dreaded, you're doing a practice test and you just always run out of time at the end of the section. You don't get to finish all the questions. You end up having to guess on the last few or something like that. In fact, in logic games, a lot of people say, I only get through like 2 of these games. I mean, they give me 4 of them and I can only get through 2 in 35 minutes. So, how do we fix that? That's what we're focusing on tonight. And a common response to the timing pressure on the LSAT and these timing issues is people just want to work faster, right? That seems like, that's actually what a lot of people will ask. People say, how do I work faster? How do I get faster? And certainly there are ways to work more efficiently. There are absolutely ways to work more efficiently in logic games or any section of the LSAT to get more done in a shorter amount of time. But the problem is some people just push themselves to go as fast as possible. And then you start making more mistakes. So working faster, quote, working faster isn't always really the option that we're looking for. What we want to do is, and maybe a better way to think about it is just using your time wisely. So you want to spend, when you're working under time conditions on the LSAT, you want to spend every moment doing something that will help you increase your score. And that sounds obvious, right? Thank you, Captain Obvious. Of course, that's what we want to do. The problem is that we often are doing things when we're working on the LSAT that are not helping us increase your score. They're not helping you increase your score. You're doing something that's wasting time. You're falling prey to a time vampire. So we're going to talk about how to kill these time vampires tonight. We're going to talk about, here's my little time vampire picture. If you were here for the January logical reasoning killing the time vampires session, you saw this goofy little picture here. We're going to be using him again tonight. Time vampires are anything that suck up your time on the LSAT. And some of these are just habits. They're kind of natural test-taking habits that people have, or things that are kind of natural to do on a time test that actually don't work well for you. Some of these are intentional traps that they're the hired time vampires, right? They're the intentional traps that the test writers set to slow you down. They do that. The people who write these tests, the people at LSAC, intentionally do things to try to slow you down. And so we're going to talk about how to defeat that. And we're going to start by playing a logic game from the June 2007 test. This is one you've seen before. Just go ahead and do it again. If you have some scrap paper laying around, paper and pencil or pen, I'm going to give you a little time to work on this, and then we'll talk about it. If you're totally new to the LSAT, you're not that familiar with logic games at all, or you've been struggling with them, you're not really sure how to deal with them, just do the best you can. Whatever you see on this next screen, just do the best you can with it. I'll give you a little bit of time to work on this, and then we'll talk about it. All right. So here it is. Here is a for real logic game. All right. What I'd like you to do, if you would, is let me know how far you've gotten so far. How far did you get with this so far? In the chat window, go ahead and hover your mouse over the bottom of your screen there. Click the button that says chat, and then type in the chat window, and this will just go to me. This is just going to me privately. How far did you get? Put an A in the chat window if you did the initial setup for the game. B, if you were able to answer one question. C, if you answered both questions. Where are you at right now with this? How far did you get? Okay. See some answers coming in. All right. Okay. A lot of B's. No clue what to do. All right, you're in the right place. We're going to talk about that. Good. Thank you for your honesty. Usually people are, usually there's one or two people who say that. All right. So a lot of B's, some A's, some I'm lost. So one of the things to, you know, when we talk about how do you avoid getting slowed down with these logic games, how do you work efficiently and avoid, how do you kill the time vampires? You got to beware of the cold shock response. So this is a real thing, right? If you fall in cold water, your body does this thing, like it's involuntarily inhales and like tenses up. It's a very kind of unpleasant response to falling in cold water. It also happens on the LSAT. So, you know, a common thing, and this happens, you know, it's happened more than once. So somebody takes a, a philosophy class as an undergrad, and your philosophy professor says, you're really good at debating arguments and understanding arguments and debate. You should go to law school. You ever thought about going to law school? And you go, really? Law school? Wow, lawyers make a lot of money. Yeah, I do like debating arguments. Yeah, I should go to law school. So you find out about this LSAT thing that you have to take, and somebody says, oh yeah, that's all about like logic and arguments and stuff. You go, okay, cool, I'm good at that. I can do that. So you sign up for the test, you drive to the test center on test day, and you go and you sit down, and they give you the test book, and they say, okay, begin. And you see this, and you go, oh, what is this? This isn't arguments. This isn't debating, so there's that initial shock of, and this happens to people, right? This happens to, I think, quite a few people who don't really prepare for the test. They go in, they take the test, and they're just not prepared. These logic games really bowl a lot of people over. So where this also happens is once you've been studying, the LSAT for a while, you get a book, or you come to one of our classes or get a tutor or something like that. And then you start learning about these games, and you learn that, okay, there are common game types. You learn that, how to work on these things. And you start being able to recognize some of these games when you see them, and you know what to do right away because you've studied them, right? And then every once in a while, you're going to see one that is really weird or that you haven't seen before. And you go, oh, what do I do? This isn't the kind that I know how to do. And you get that, shock response. And that can happen to people who have really spent a lot of time preparing for the test. There are people who, have spent months and months preparing for this test, and then they go take the real LSAT. And the test writers are really good at every once in a while coming up with something that nobody's really seen before. Even this game is a little bit weird. If you're familiar with ordering games, there are a few things about this game that are a little weird. So it's one of the things we have to do is when you first start playing a game, you have to avoid that whole like, oh my gosh, what do I do? And the way you avoid that is by having a clear process. There are two things. You want to have a clear process. One of the things we talk about most in our classes, in our books and our LSAT courses, is our 4-step process for logic games. So every time you play a game, you want to follow this process. You want to have a clear process and follow the process. So the first step is to picture the game and start your diagram. So when I first turn the page and I look at this game, they give me this scenario, this little setup situation, and then they give me some rules. And I'm going to read all the way through this and try to get a sense for what's going on, just a sense of generally, what is going on in this game. And so to me, and then once I've read it all the way through, now I'm going to go back and just look at it piece by piece. And I want to create a diagram. Diagramming is an important part of logic games. You don't want to have to go back and read all these rules every time that you're, trying to answer a question. So before you look at the questions, before you start working on questions, we're going to create a diagram to help us visually represent these rules that they're giving us. And so as I read this, again, let's break it down piece by piece. Company employee generates a series of 5-digit product codes. Okay, we're going to have 5-digit codes. So they're not telling us exactly what the codes are, but we have, 5 digits, 1, 2, 3, 4, 5. And we know what the digits are going to be. They're either going to be 0, 1, 2, 3, and 4, and no others. That's it. So this tells us, and then also we know each digit occurs exactly once, and then they're talking about the second digit and the third digit and the fifth digit. So this is an ordering game. What they're asking us for is all the questions are going to be about these 4 numbers and what order they go in, right, in the in the code. So that's the first thing you need to understand is just the basic structure of the game. And one very common type of game is an ordering game where they're giving you either numbers or people or some kind of cold medicine that's being ranked best to worst, and your goal is to put them in order. So our base diagram that we're going to draw here to start is going to be a number line. 1, 2, 3, 4, 5. Those are our digits in the code. These are the numbers we're putting in those spaces, 0, 1, 2, 3, and 4. And we need to keep track of what the digits are. What is the second digit? What is the first digit? What is the third digit? So that's our base diagram. And then we want to notate the rules. We want to have some kind of, again, I don't want to go back and read these things every time. I want to have some kind of visual representation of the rules. So the codes use these numbers and no others, all right? That's already on there. Each digit occurs exactly once in any code. Okay, so I'm just going to put like 1 times each. once each. Something to indicate, to remind me that each of these get used exactly once. The second digit has a value exactly twice as the first digit. Okay, they're talking about the first and the second one here. The second is exactly twice. So I'm just going to draw a little arrow under here, like 1 times 2 equals the first one times 2 equals the second one. All right? And then the value of the third digit is less than the fifth digit. Okay, let me draw a little arrow connecting the third and the fifth. And what does this tell me about them? The third one is less than the fifth digit. Give me an okay in the chat window if you had something like this on your paper. This is like the first thing you did. Give me a yes in the chat window and okay. Or no if you didn't. Okay, some people did. Excellent, excellent. Okay, some people said no. So this is the first step in the process. You read the story they tell you and the rules, and we want to create a diagram that represents all this visually. Now, you know, one thing to remember about your diagram, and this is one thing that happens if you're studying, again, this gets into the time vampires, right? You start studying, you read books, you go to a class, and you start learning about all these logic games, and you get this idea that there's this specific type of diagram that you should draw for specific game types. So we call this a basic ordering game, and we would use this number line diagram to represent, you know, any game of this type that's, you know, going to be similar to this one. And this is a good way to represent the rules. But remember, this is all your scratch work, right? This is all your scrap paper. Nobody's grading you on this. This is your tool that you're going to use to answer questions. So, you know, you don't have to write things exactly the way I did here, as long as you have your own clear way. Like if you wrote something a little different here or a little different here, a little different here, as long as it's clear and helps you understand what that rule means and how that rule fits on that diagram, then that's good. Don't stress yourself out trying to figure out the exact perfect way to diagram things in these games. It's your scrap paper. Just make it accurate, make it work. Sometimes just having something on paper is better than spending, you know, 15 seconds trying to figure out how to do it exactly perfectly right. Okay. Any questions about this right now? Is this all good? Everybody give me an okay in the chat window if you're following along so far. If even if you didn't do this on your own paper, but you know, is this making sense? Okay, I'm seeing some okays. So you know, if you have a question, you can say, hey, I have a question, you know, in the chat window, and I'll try to notice that and stop and give you a chance to ask a question. All right. So in order to work efficiently, work effectively, spend your time wisely, make sure you have an effective, pay attention to your overall process, the steps that you're following every time you play a logic game. There should be a scaffold, a framework, a set of steps that you follow every time. That's your process. And then remember, the trick is always breaking things down into smaller pieces. Read each part of that little story they tell you in each of those rules, and just one piece at a time, try to understand what's going on and get it on paper. All right. Now, this is the point very often where people fall prey to a very serious, deadly time vampire. What a lot of people are going to do is get this on their paper, and then they're going to try to write out different scenarios. So somebody will go like, oh, okay, well, okay, so the first has to be exactly twice the second. So, okay, the first one, if the first one's 1, that means the second one's 2. Okay, and then what else? Well, I guess the third has to be less than the fifth. So, well, the third could be 0, and then well, we could have 3 here and 4 here. Okay, well, then it could be 1, 2, 0, 4, 3, and that would work. And you keep going and you keep going. And what people very often do is try to write out every possible solution to the game. If you do that, if that's your normal next step, stop. Because that's a time vampire. That's a trap. It's a rabbit hole that you'll fall down. So for this particular game, there are actually 6 solutions. That's pretty limited. There could easily be, you know, 20 solutions to one of these games. And you could easily spend 5 or 10 minutes just trying to write everyone out and then not get to any of the questions. And people will do that. That's one of the reasons why people only get like 2 questions done in a game. So if you're having timing issues and this is your normal thing to try to write out every solution or a bunch of solutions, don't. Like, get rid of that first. That's one of the main things to get rid of. Now, there is a very limited situation where we might write out solutions. Like at this point, we might come up with certain solutions, but just the idea that if you think the idea or the goal in these games is to write out every possible solution or as many solutions as you can, if that's what you would be doing right now at this point, don't. Like, get rid of that. There are more effective ways to do it. What's more effective is the next effective step is once you have this visual notation, this diagram and notation of the rules, we want to make inferences. If I say inference in a logic game, what am I talking about? Does anybody know what I mean if I say, you know, what inferences can we make here? Or even just generally in the chat window, what does the word inference mean to you? If I start talking about making inferences, what am I talking about? Any ideas? Off the top of your head. Not, you know, nobody's going to, logical next step. Okay, that's a good answer. Tyler, yeah. Summer says deductions or assumptions. Okay. Implicit that's indicated by the rules. Feifei, yeah. Logical conclusions. Excellent. Okay, really great answers coming in here. I'm going to give you like 2 criteria for an inference. Now, inferences are used a few different ways in the LSAT. There are some inferences that are a little bit less strict than this, but in logic games, when I'm talking about making inferences, inferences are things that are not explicitly stated in the rules, but must be true, just like the rules. Okay? So those are the 2 criteria for inferences. A lot of the definitions you guys are giving me are good ones. I'm just going to narrow it down specifically for logic games. Inferences in logic games are not explicitly stated and must be true. Can somebody give me an example in the chat window of an inference, or if you have that unmute button available and you want to hop on the mic, can somebody tell me is there an inference that you see in this game that we can make? A logical conclusion that we can make based on the information we've been given. Something that always must be true in all solutions. Ah, okay, so there's a good one, right? So if the first digit always has to, you know, the second digit always has to be twice what the first one is. And then, you know, like the first one can't be 0 because 0 times 2 is 0, and we can't have 2 zeros. If it's 1, then the next one is 2. Okay, it can't be 3, it can't be 4, so we're either going to have 1 or 2 for the first digit and then 2 or 4 for the second digit. That's an inference. There are only 2 possibilities for the first digit, 1 or 2. There are only 2 possibilities for the second digit, 2 or 4. Those must be true. Every solution to the game. Now, Kenny said 0 must be in the middle, so I guess you mean spot 3 must be 0. Is that true? What if I have 1 here and 2 here? Does that have to be 0? Couldn't this be 3, and then my last one could be 4, and that could be 0? So you got to be careful there. That's over-inferring, and you'll do that sometimes, right? You'll do that sometimes and realize, oh, wait, I went a little too far. And that's okay. You learn to be, you got to make that mistake a few times and recognize it. But if you have trouble with questions, if you're playing a game like this and you have trouble with the questions, always go back and look at any inferences that you made up front and ask yourself, you know, did I make an incorrect inference? So, Feifei, you asked about frames in the chat window. I'm going to try to get to frames. Frames are a really useful tool in logic games, and I am going to try to get to those and talk about those tonight, if at all possible. We're just not going to talk about them right now because they're very specific, and I want to make sure that we talk about them correctly. Even if you're using frames, this is still important. You still want to do, frames are not a replacement for what we're doing right now. I would always want to do what we're doing here before I create frames. Maybe there are a few very limited situations where I weren't, and I would say inferences are more important than frames. Inferences are going to help you in every game if you make valid inferences. Frames only apply to a very limited number of games. So we'll try to get to those in a little bit and talk about what frames are. But for now, I'll show you the inferences that we can make in this game. Either 1 or 2 have to be first, either 2 or 4 have to be second. 4 can never be in spot 3 because if 4 is the highest number we have, and if 4 is in spot 3, then it can't be less than 5. Likewise, 0 can never be in spot 5, because if 0 is in 5, how do we have anything less than 0 in spot 3? So these are things that, these are the inferences, the upfront inferences we can make in this game. These are all things that, none of these things are explicitly stated in the rules. There's no rule that says 3 can't be 4, but all these must be true based on the rules. So, and these are common ways of making inferences. Like C, always try to notice if the rules exclude certain elements from being in space. It's a very common question, very common inference type. Sometimes there are ways to combine rules, like we combine these, the fact that the codes use digits 0, 1, 2, 3, and 4, they all occur exactly once, and then the second digit has a value exactly twice that of the third digit. We're combining these rules together to come up with these inferences about the spot 1 and 2. So that's another common way of making inferences, is see if you can see how rules connect to one another. Just thinking about those two things will help you improve your ability to make inferences. Now, the thing I'm going to tell you about inferences is they're useful, but don't be paralyzed if you haven't, if you don't always make them. You can play games pretty well even if you miss important inferences. They're helpful. I'm not going to tell you they're not helpful, but don't get too hung up if you're not making inferences. Just always go back when you play a game. If you're taking a practice test or you're working on a game in practice, always go back after you've played it and sit there, get a nice cool beverage, put your feet up, and take a little time to look over your diagram and try to make those inferences that you missed initially when you first played the game. Looking for inferences that you missed is an important part of reviewing. All right, so now we've made inferences. Getting into the killing the time vampires theme, what we just did was focused very specifically on what must be true always in every solution to the game, and not stated in the rules. We didn't go down the rabbit hole of trying to come up with every possible solution. Just thinking about what must be true but is not explicitly stated, we were able to come up with a couple of very useful pieces of information about this game. All right, so next step, the third step. Now this is the point where everybody's like ready to answer questions, but we always encourage you before you answer questions to do what we call the big pause. And this can be the key to cracking some logic games wide open. Some games, some pretty tough games, doing this step correctly can be the key to making questions a lot easier to answer. So what we do in the big pause, basically two things. Are there any elements without rules? So this game's a little tricky because we have all these numbers, and technically none of the, other than this first rule, none of the, which is really just telling us what the elements are, these are our elements, what are the things that we're placing in these spaces. None of the other rules really mention any of these digits, but all of these rules about the positions do kind of apply to all the digits. So, in some games we're gonna have an element that isn't governed by any rule. Like maybe if this game was slightly different, we would have a situation where like, oh, 1 isn't covered by any of the rules. None of the rules really apply to number 1 there, element 1. So we would circle 1. Anytime you have a rule that isn't, or an element that isn't covered by any of the rules at all, the most free thing in the game, you would go ahead and circle that. And then we also want to take a moment and think, what's driving the game? And a good way to think about that is like, what's the most restricted thing in this game? What do you guys think is, and this could be an element, this could be a rule, this could be a couple of elements together, a couple of spaces. What do you think is the most restricted part of this game, using the word part kind of loosely? Is there one of these numbers that's really restricted as far as where it can go? Are any of these spaces really restricted? What do you see as the most, somebody tell me in the chat window, or hop on the mic if you want, unmute and hop on the mic. What's the most restricted thing in this game? Maha says 4 is really restricted. I think that's a good, yeah, because 4, it's restricted in that space 1 or 2. It's one of the 3 numbers that can go in these spaces. One of the only 2 numbers that can go here. And also it can't be 3. So it's kind of restricted in where it's going to end up. 0 is pretty restricted too, right? It can't be one of the first 2. It also can't be the last. So really we know that 0 has to be, it can't be one of the first 2. It can't be the last. That could be another inference right there. That actually 0 has to go in either 3 or 4. We could add that to our diagram. Everybody see that? It can't be 1 or 2. It can't be 5, so it's got to be 3 or 4. There's another inference. Sometimes you'll do that. Sometimes by thinking about, what's the most restricted thing Oh, wait a minute, 0. Hey, wait, 0 can only go in 2 places. You know, that'll lead to another inference. I'm just going to leave that inference off here, but that's a really good one. All right, so again, we're just taking, you know, this could be 30 seconds, 20 seconds that you spend looking at your diagram, thinking about these 2 specific things. Are there any elements that are just not covered by any of the rules? And what's the most restricted thing in this game? What's driving the game? What's the most limited thing in the game? Okay. So but always take a few minutes to do that. If you're not doing this, that's something to change in the way you play logic games. Always, once you've created your initial diagram and made inferences, take a moment to look at the diagram and think about these 2 things before you answer questions. All right, so now we're ready to attack the questions. That's step 4 in our 4-step process. We're going to attack the questions. So I'm going to show you a question. I'm going to give everybody about a minute to work on the question. If you come up with an answer, go ahead and A, B, C, D, or E, put your answer in the chat window if you would. Okay, so that was about a minute. And if you're wondering, around a minute is if you can answer a logic games question in a minute or less, you're doing well. That's kind of our goal, our target we're shooting for. I saw some answers coming in the chat window. That's great. A few different answers. So what I want to do is try to get everybody on board with what the correct answer is here. One of the first things, so it says, which one of the following must be true about any acceptable product code? So any valid solution, what must be true? We call this an unconditional question because this is asking you for something that must be true in every possible solution to the game, must always be true. They're not giving you a new condition to base the answer on. We'll see that in a minute. So we always want to make sure that we understand, like, what is the question asking? So how many valid solutions to the game? Let's not even worry about what answer choice A actually is. How many valid solutions to the game must contain the correct answer? If it's asking us for something that must be true about any acceptable product code, if I think about all the possible solutions to this game, and there are, you know, multiple solutions, how many of those solutions, for how many of those solutions must the correct answer be true? How many of those solutions must contain the correct answer? So the answer is all of them, right? Maybe this is obvious, but the answer is all of them. If it's asking you for which of the following must be true, then whatever the correct answer is, if A is correct, then it must appear in every possible solution to the game. So another way to think about this is, how many counterexamples do I need to prove an answer choice wrong? Just one. If I can come up with one example to prove that A does not have to be true, then I can eliminate A. So this is something that is a little bit different from the normal way we take tests. Normally in a test, you go looking for the right answer, right? You read the question, you look for the right answer. On the LSAT, it can be much more useful and valuable to look for wrong answers. And I want to answer, somebody put an answer in the Q&A real quick. I just want to answer that. This is coming from PrepTest, the June 2007 PrepTest. This is the June 2007 PrepTest, section 1, question 2. So good question. All right. Okay. So what I was saying a moment ago is what we want to do in answering questions on the LSAT, what's just as valuable as finding a right answer is eliminating wrong answers. So to look at this answer and say, is it right? I have to know it's right in every possible solution. To look at this answer, any answer, and know it's wrong, I just need one counterexample. So if we look at this answer choice A, the digit 1 appears in some position before the digit 2. Okay, well, can I put 1 after 2? Can I put like 2 somewhere early and then 1 after it? Well, let me try that. So what I'm going to show you, this is a simple process, common process in logic games in the LSAT. It's called testing an answer choice. So if 2 is before 1, that must mean that 2 is first and 4 is second. Okay, well then, where am I going to put 1? I don't know. Let's put 1 at the end. Let's put 0 here and 1 at the end. Is 3 less than 5? Yep, 3 is less than 5. So that must mean spot 3 is less than spot 5. So let's just put 3 here. And there could be other possible solutions, right? All I'm trying to do is come up with one solution that shows that the digit 1 can be after the digit 2. So all I have to do is come up with one counterexample that's valid, that follows all the rules, and I can prove that A is wrong. I look at answer choice B. The digit 1 appears in some position before the digit 3. Okay, can I put 1 after 3? Well, wait a minute. I already have that, right? I just happen to have, sometimes you get lucky. I happen to have already created a diagram where the digit 1 is after the digit 3. So I can eliminate B too, because I have one counterexample. That's all I need to prove that B isn't right. The digit 2 appears in some position before the digit 3. Okay, well, can I have 3 and then 2? Well, so that must mean 2 can't be first. So, because other than, there's nothing that goes before 2 if it's first. So that must mean 3 is first. But if 3 is first, then 2 has to be twice 3, which is 6. And I can't do that. There is no digit 6 to use. So right away, I see that I cannot come up with a counterexample. There's no way to come up with, I can't even come up with one counterexample to disprove C. So answer choice C is my correct answer. It must be true. So you see what we did here. For each of these answer choices, all I did was try to come up with a counterexample and quickly created a hypothetical. Now this is where you create hypotheticals. In questions, we don't want to try to come up with every possible solution to the game up front, but in real questions, we're going to use hypotheticals a lot. Now, Feifei asked a really good question. On the real test, how do we tell if something is needed or not need to be tested this way? What I'm going to say is there are actually multiple ways to answer this question, and I'm going to try to have time here to show you a different way of answering this particular question. But if you're not sure what to do, this would be a valid way to answer this question. Because if I just read the question, if I know what it means to say must be true, I know right away, oh, all I have to do is come up with a valid counterexample. Well, how long do you think it would take you to create just an example that follows all the rules to show that 2 can be before 1, to show that A doesn't have to be true? 20 seconds? 20 seconds maybe to create an example like this. Oh, and then you use the same example to answer. So, you're done with B in like 10 seconds. So now we're taking like 30 seconds so far to answer this question. And then I start to try to create a solution for C. And so I'm going to suggest that with the method that I'm showing you, you could answer this question in a minute, which is great. If you can answer a question in a minute or less, you're doing great. Now, yeah, there are other ways to answer this question, and I will, I'll talk about those in a little bit. But the point I want to make here is there are a lot of different methods that you'll see for answering questions, even a pretty straightforward question like this. But if you don't understand what the question is asking, if you're not really keyed into the idea of, well, what does it mean where it says must be true? How many solutions to the game must contain the correct answer? How many valid counterexamples do I need to prove that this answer is wrong? If you don't really have a clear idea of that in your mind for each of these questions, then it really doesn't matter. I could show you like a much faster way to answer that question, but it's not going to matter if you don't clearly understand what the question is asking and the answers to these questions I'm showing here. How many valid solutions to the game must contain the correct answer? How many counterexamples do I need to prove it wrong? If you don't understand that you only need one counterexample to prove an answer wrong, then it doesn't matter what solution I show you, it's not going to be that helpful. So the good news here is you can take this, you can download this practice test from the LSAC website and just look at, all the logic games and do, try to do the setup, your initial diagram, and then play this game with yourself with each question. Right? Just read the question stem and make sure you understand what the question's asking. How many solutions does the correct answer need to appear in? How many counterexamples do I need to prove it wrong? And you can actually go a long way to understanding the test better and answering questions better just by being clear about that. All right, so let's look at another common type of question. So you want to have an effective process for each question type and understand what the question is actually asking. And then, if you understand those things, then any explanation you see is going to make a lot more sense. So if the last digit of an acceptable product code is 1, let's look at another question. Let's keep attacking these questions. So let's go back to question number 1. If the last digit of an acceptable product code is 1, it must be true that. Okay, so you would look at this and say, well, wait a minute, so this is another must be true question, right? This is the same kind of question that we just saw before. Which of the following must be true? But this is actually a very different question type. So read the question. Notice what the question is asking. This is what we call a conditional question because they're giving you a new condition. If the last digit is 1. So the answer to this question is based on a condition where the last digit is 1. So for this type of question, we're not going to look at the answer choices right away the way we just did. I want you to, in fact, if you have to, when you see any question like this that gives you a new condition, any question that starts with if or has this new if, this new scenario. So they're giving you a specific, it's almost like they're giving you a new rule that you're going to use to answer question 1. And I want you to actually do this. I want you to cover the answers up with your hands when you're working on a question like this with your hand. And then the first thing you want to do is don't draw anything on your original diagram, but create a new diagram next to the question, a new temporary diagram. Last digit is 1. Okay, and draw that, this new condition they're giving you. Now, if the last digit is 1, what do I know? Well, let me go back and look at my diagram. So where do I see 1 on my diagram? I see it here. So that tells me that spot 1 has to be 2, which means this next one has to be 4. Okay, so I know what the first 2 are. What else do I know? Well, wait a minute, who's left? So I got 0 and 3 left here. Let me write them down. So what do I know? 3 has to be less than 5. So which one of these is less than 1? 0. So 3 is there. So again, this is a case where I am going to create hypotheticals. I'm creating a valid hypothetical to test or to based on this new rule that they're giving me. Before I even look at answer choices, I want to get this on my paper. I want to understand the inferences that I can make based on 1 being the last digit. And probably the biggest mistake, the biggest time vampire you will fall into is not doing this pre-work first. The big time vampire that people fall into is they start looking at answer choices before getting this on their paper. So like this might take like 20 or 30 seconds. It wasn't a complicated process. I just put 1 in the last spot and I looked through all my rules for the 1. And what does that tell me? Oh, it tells me 2 is here. Well, what else does that tell me? Where are my 2s here? Oh, that means 4 is here. What else do I know? What do I know about spot 5? So it's very methodical, looking at what you have on your diagram and then looking to your initial diagram to fill the rest in. But now it must be true that, oh, look, it's answer choice A. Look at how fast I come to the right answer. So again, it's a process. When they give you a new condition, this is a conditional question. They're giving you a new condition. Diagram that new condition. Create a separate temporary diagram that new condition, and then see what other inferences you can make based on your rules, based on that new condition. Follow that inference chain, and then once you've done that, then look at the correct answer. Look at the answers and compare the answers to your temporary diagram. Second, you could look at the rest of these answers and see that none of them have to be true. None of them are true in this diagram. So let's look at another question where this same principle applies. And this one seems more complicated, right? I just want you to look at I'm going to cover up the answer choices. I just want you to look at, ooh, that's an ugly blue. hang on here. Hang with me. I want you to look at the answer. I don't want you looking at the answer choices. I just want you considering this new condition first that they're giving us. So if the third digit is not 0, well, that seems weird, right? Because the last time that the last question, they were giving me something that I could put on my diagram, right? I could put 1 right in the diagram last time. This is saying the third digit is not 0. Well, what do I do now? Same thing, nothing different, nothing new here. We cross 0 out under 3. That's the new condition. It's not 3. All right, well, so it's not 0. The third one is not 0. So you might think you're stuck here. Well, what can it be then? If it's not 0, what can it be? Well, it can be 1, 2, 3, or 4. So let me write those down, 1, 2, 3, and 4. Let me give myself a little more room here to write. So all I've done is thought about, they've given me a new condition, I've written it on the page, and I've thought about the implication of that. So what happens if it's 1? If it's 1, then this must be 2 and 4 here. And who do I have left? 3 and, oh wait, I have 0 and 3 left, so this last one can't be 0, it's got to be 0, 3. All right, so that's what happens if it's 1. What if it's 2? Well, if it's 2, then, well, wait a minute. If it's 2, I'm kind of stuck because I have to have a 2 over in spot 1 or 2 somewhere. So that's not going to work. Having 2 can't be in third spot. So what if it's 3 in third spot? Well, if it's 3 in third spot, I guess could this be 1 or 2 or 2 or 4? Well, wait a minute. If it's 3 in third spot and the 5th spot has to be higher, greater, that means the 5th spot has to be 4. So this must be 1 and 2. So that must be 0. So what I did was I wasn't really sure about what's going on over here in spot 1 or 2. So let me think about what else I know. Oh, I know spot 5 has to be greater. That means 4 must be there. And from there, I can fill in the rest. So what if this is 4? If this is 4, that means these two have to be 1 and 2. Can anything, well, wait a minute. If this is 4, what's going to be greater than 4? What can I put over here in spot 5? Nothing. So that doesn't work either. Sometimes you'll start creating a hypothetical and you realize, oh wait, that doesn't work. I can't do that. So that's okay, right? That's totally okay. Just cross it out. If you start creating a hypothetical and you realize that it's not going to work, just cross it out. So what we end up with here, and again, maybe that took me a minute. Maybe it took me a minute to figure all this out. And the thing is, it feels like so much time. You take a whole minute to write out these, 4 scenarios, to consider these 4 scenarios and realize that 2 of them don't work. People, people won't do it. People refuse to do it. Everybody starts looking right away at the answer choices. And I've watched people spend 2 minutes poring over the answer choices, trying to understand the answer choices and wrap their head around them. And when they could have easily just spent 1 minute doing what I did here. And then when you look at the answer choices, okay, which of the following must be true? So remember, we only have 2 valid solutions here. The second digit is 2. Yeah, A, alpha, is correct. Second digit of the product code is, oh, wait a minute, no, which of the following must be true? Well, wait a minute, because I have 2 possible solutions. It could be either 2 or 4, so they have to both be the same. If it's which of the following must be true, that means it has to appear in every possible solution. So, okay, wait a minute. My eye is going to immediately be drawn here to this spot, because this is the only spot that has the same thing in both. So, if you want to save a little time, if it's asking you for what must be true, again, how many of my solutions does this have to appear in? It has to be the same in every solution. And so the only thing that's the same in every solution is C, Charlie. The 4th digit is 0. If I had just gone down the list, the 3rd digit is 3. No, the 3rd digit could be 3 or 1. Like I see there are 2 possibilities here, so I would cross that out. Feifei, wouldn't it be easier if we use the inferences? if the third digit, wouldn't it be the second digit? So I don't think you could use the inferences for sure and be certain I don't think you could use the inferences and be certain, and for this without considering the hypotheticals that we drew here. And the other thing, Feifei, so it's a good question. Feifei was asking about just answering this using inferences. And the other problem, Feifei, is what I'm trying to show you here is a process that works for what I just did here was the same exact thing that I did on question number 1, the same exact steps. I drew a hypothetical that included the new condition, and then I made inferences based on that and came up with 2 possible solutions. And then I was able to answer the question correctly based on those 2 solutions. So it's not a different process. And this is the thing. I don't want to have to spend too much time thinking about what is this question asking, and is there a different way? I don't want to have 15 different ways of answering questions. I would rather have a smaller number of ways that work for as many questions as possible. So this is where your process becomes important. There are a couple different ways to answer this question, possibly, but the way we just did it is going to let you come up with a correct answer in a minute or less. And it's very generalizable. It's a process that you can follow that'll let you answer, basically any question that begins with if, any question that gives you a new condition. Now, the other reason why I'm very happy to create these hypotheticals, like I've just come up, remember, every one of these hypotheticals that I've created for question 1 and for this question, every one of them is a valid solution to the game. So 12304 and 24103, those are both valid solutions to the game. And the reason I like having those on my paper is because I can use those solutions to answer other questions. So let's look at another question. And we're getting towards the end here, so I'm going to wrap this up with another question. Let me do it this way. Let's do it this way. Let's actually go back to question number 2, since we've looked at that one already. And remember, I said there are faster ways to answer some of these questions. So keep in mind, imagine we went back to question 1 here, and I had these hypotheticals on my page. So for question number 2, I created a solution that was 2, 4, 0, 3, 1. That was for question 2. And for question 3, we just created 2 hypotheticals. One was 1, 2, 3, 0, 4, and the other one was 2, 4, 1, 0, 3. So remember, we said which of the following must be true. So it has to appear in every possible code. So that means that these hypotheticals that I created for these 2 questions, question 2 and 3, these are valid solutions to the game. So if A is right, it must appear in every solution. So do I have a solution where 2 is before 1? Yeah, 2, 4, 0, 3, 1. So I can eliminate A without creating any new hypotheticals, just based on the existing work that I did for question 2. Or sorry, for question for question 1. This was for question 1. Let me not get my questions mixed up. So B, the digit 1 appears in some position before digit 3. Do I have one where 3 is before 1? Yeah, I have that right here. So again, I can eliminate B. The digit 2 appears in some position before 3. Do I have 3 before 2 anywhere? No, I don't. So let me skip C. The digit 3 appears in some position before 0. Well, do I have 0 before 3? Yeah, I do. So I can eliminate that. Digit 4 appears before 3. Do I have 3 before 4? Yeah, I have that here. So I can notice, just without creating any new work at all, without creating any hypotheticals, if I had skipped question 2 and done question 3 first, and then not gone back to question 2, I could have very quickly eliminated 3 answers, and C is the only one Now, you know, I don't have any hypotheticals that show that C is happening, but I have hypotheticals, 3 out of these, just 3 solutions that I created. I have solutions showing that A, B, D, and E don't have to be true. They don't have to appear in every solution, so I can eliminate them. So again, if you understand what the question is asking, that also lets you understand how to use hypotheticals that you create for other questions to go back and answer questions that are really difficult. This is you know, getting back to time vampires. And I said that some of these time vampires that you're going to see are actually intentional, that, you know, LSAC sets these traps for you. And I see a question interesting. This ties right into a question that Maha asked in the Q&A. So the answer, Maha asked, is it better to go in the order the questions are given in a game, or is there any way you can tell when, where you can leverage working out hypotheticals in a later question to answer the earlier ones? The answer to your first part of your question, is it better to go in the order questions are given? I look at every question in order, but I definitely don't answer them in order. I would be very willing to skip question 2. Now, there actually is a pretty fast way to answer question 2 based on the upfront inferences that we made. But even if you hadn't made any upfront inferences, you could have still answered this question just based on the hypotheticals that you created for question 1 and question 3. So to kind of tie all this together, if you run into a question and you're not sure what to do, if it seems like a really difficult question, or if you realize that the only way you know how to answer the question is the way we answered this question 2 earlier in the session, remember where I created a hypothetical to try to test each answer choice, and you don't want to do that? So almost before I would go and try to test every answer choice, I would skip this question and go back to it. I'm going to go and answer conditional questions, especially if I see that there are conditional questions later in the game. I'll go answer those first. I'll use the hypotheticals that I create to answer those conditional questions, question 3 and question 1. And then when I'm done with those, I'll go back and use whatever hypotheticals I created to try to answer, you know, the questions that I skipped. So, you know, the second part of your question, Maha, is how do you know when to skip a question and go back to it? The way that you know is if you look at a question and you look at each answer choice and like, I'm either going to be able to immediately answer this question based on what's my diagram, based on what's on my diagram. I would look at each of these answer choices and say, you know, do I see anything on my diagram that lets me like select this and say it must be true? If I can't, then once I've looked at each answer choice, if I haven't been able to answer it based on what's on my initial diagram, based on the initial inferences that I made, then I'm very willing to skip it, go ahead and answer other questions first, and then go back to it. So I guess the simple answer is, you know, the thing about conditional questions, I'm just going to go ahead and clear this off. The thing that I like about conditional questions is they give you a very straightforward starting point. You know, each of these conditional questions we looked at gave you something concrete that you can put on paper and work with. And that's the thing that makes conditional questions great, if you take advantage of that. If you actually are willing to take a moment and put something on paper and work with it, right? If you're actually willing to draw this out. Okay, I got 1 here, what do I know? Okay, I got 0 here, 2, 4, etc., right? So, you know, the nice thing about these conditional questions is they give you something concrete to work with that you can then go back and use as leverage against questions that aren't as concrete, that aren't giving you something really concrete to work with right off the bat. All right, so, and again, you know, there are, you know, multiple ways to approach these questions. There are always multiple paths through any logic game. And you could look at another instructor, you know, one of our other, very possible that, you know, maybe a couple months from now, one of our instructors decides to do a free prep hour and says, hey, let me show you my way of doing this game. And they'll show you something very different. So, but what I'm going to say is the common thread with all these, no matter what specific method you're using and specific approach that you're taking to logic games, the basic steps for killing the time vampires apply, right? So make sure the big takeaways here, the big picture takeaways are make sure you have an effective process, overall process. Picture the game, read through the whole thing first, and then go back and break anything that's complicated, break it down step by step into smaller pieces. Don't go down the hypothetical rabbit hole. Yes, when you're answering questions, yeah, I'm very willing to create hypotheticals, possible solutions to test things out. But right up front, avoid that temptation to try to draw out every possible answer. Have an effective process for each question type. Make sure, and a lot of this comes from just understanding what the question is asking you. What is the question actually asking you? And then what's the most effective process to use based on that? But I would say 5 is even more important than 4, because if you don't really, take the time to, and these question types tend to repeat themselves. They really do. You're going to see questions just like the ones we looked at. Which of the following must be true? If so-and-so is happening in spot so-and-so, which of the following must be true? Which of the following could be true? I mean, they're very common. The question types we looked at tonight, unconditional questions and conditional questions, the most common types of questions in logic games. So you'll see those types of questions again and again. Make sure you understand what you're asking, what that question is asking of you, and what your effective process is for answering that type of question. And again, if you're watching using different resources, you're watching other free prep hours, I mean, you always have to go back to 4 and 5 here. Make sure you understand what the question is asking. That'll help you understand why the instructor is recommending that you use that specific process, or why the instructor is showing you that process.